In this month of November 1977, I'm completing my 36th year of working at Bell Helicopter Textron and its predecessors. 3 years ago, I retired, and since then have been acting as a consultant. Recently, among other things, I found an opportunity to compile a motion picture, which I would like to narrate for you. The title of the film is The Birth of the Bell Helicopter. But first, a few words about Arthur M. Young, the inventor of the Bell helicopter. A native of Philadelphia, Young was born in 1905. He studied mathematics at Princeton, where he graduated in 1927. He felt a very strong urge to invent something radically new and spent some time casting about for a field of activity. By December of 1928, he had finally decided to devote the next 15 years of his life to inventing and creating a helicopter. Arthur Young's initial method was to spend a week or so in various cities, such as Philadelphia, Washington, Detroit, and New York. He would check into a hotel room and spend his days in public libraries, looking up all the entries he could find under the word helicopter. In this way, he became well versed in the patent literature and the history of early helicopter research. He found that a helicopter had succeeded in hovering for a few minutes in Ohio in 1923, and he read accounts of the experiments of many pioneers in the field. His next step was to set up a small aeronautical laboratory in the barn of his family's home in Radnor, near Philadelphia. In 1929, if you announced that you were working on a helicopter, you were considered eccentric, to say the least. And if you were a young man of independent financial means, as Arthur Young was, it took lots of courage and persistence to devote your full energies to what was thought of as a crazy invention. But persist he did. From the start, he developed a habit of taking movie films of all of his experiments. After he joined Bell in November of 1941, fortunately, he continued this habit. And as a result, there are hundreds of feet of film of excellent scenes of the development and research that led to the production of the Bell helicopter. After this production started, Arthur Young gradually withdrew from the company in the late 1940s in order to devote full time to what he considered his life's work. This, in his own words, is a synthesis of science and fundamental philosophy. Recently, he has published 2 books which partially explain this work of his. The first one, The Geometry of Meaning, and the second one, The Reflexive Universe. But now back to those cans of movie film in the archives of Bell Aerospace Textron in Buffalo, New York. The first part of the film you're about to see is mainly cut from scenes from a film which Arthur Young himself made before joining Bell. It was for the purpose of explaining and promoting his ideas, especially the concept of the hovering stability of a helicopter. But the very first scene you will see was taken by me in 1931, when I interrupted my studies at Harvard to act as a sort of laboratory assistant to my friend Arthur. This first scene will show a 10-foot diameter model with propellers at the tips of the blades. The propellers are driven by a centrally located reactionless gear driven by an electric motor. The reactionless gear was the subject of Arthur's first patent. Now, this flight is typical hovering instability. The next scene is about 9 years later in 1940 in Arthur's barn in Paoli, Pennsylvania. Hovering stability tests. These scenes are taken from the movie entitled Principles of Stability. Those are independently hinged blades, but nevertheless, in spite of those hinges, the rotor follows the mast perfectly. Now, there were authorities at that time who thought that that would not be the case. In fact, it was even in printed reports. But Arthur quickly proved what is now obvious, that even the hinges will not prevent the rotor from following the shaft very rapidly. This is typical of the model testing that he did. It's a coaxial design. The rotor on the bottom, which you see flickering, is merely to take the torque out. And that is a pair of balsa blades, whereas the upper rotor is the lifting rotor. The torque between the two is equal, but since the upper one turns faster, it has most of the power. Arthur had to learn mass production of these little model blades. In fact, he taught a neighboring farm boy how to make them so that he could quickly rebuild and make the flights again. Now, there's the stabilizer bar, and this is December of 1939 when he hit upon the idea of the bar. Notice how the rotor no longer is attached to the mast so rigidly that it lags behind when he rocks the model in that cradle. There, immediately you see that, of course, it flies perfectly stably. That's inside his barn. He's even unable to upset it by jiggling it that way. And so he can make free flights outdoors. Now, this model has no control, and so it's being blown by the wind. That's the reason it moves toward the left. The only control, of course, is to the voltage to the motor, a 110-volt motor to which he applies a 210-volt line with a rheostat. The fuselage legs seem to be spinning there simply due to residual friction in the gear. Here he's replaced the bar with a flywheel. The flywheel turns at the same speed as the motor, and the rotor is turning 1/13 the speed. Now notice when he rocks the cradle that the rotor hardly follows at all. In fact, when he leaves the cradle over to the side, the rotor takes an extremely long time to take on the same angle. Now, this flywheel allowed Arthur to make a remote control model, because now he could simply tilt the flywheel by some external means and make the helicopter fly in the desired direction. He added that white paper tail there just to reduce the fuselage spinning due to friction in the transmission. His next idea was to make a remote controlled model and to use it as a demonstration to promote the idea of a project to make full-scale helicopters. Now, he, with this model, managed to measure rate of climb. He got up as high as 200 feet in the air with it, but, of course, had to wait for extremely calm weather to do so. Here's a nice jump takeoff. You can always see those vanes on the bottom, but the lifting rotor, of course, when it's turning fast, it becomes invisible. So about this time, he decided to make a really nice remotely controlled model, and here it is. He's going to demonstrate it for us. We'll see him take the cowling off now and show the anatomy. The black thing just above the cowling is the swash plate. And you can also see that harness, which is holding it above its center of gravity. Now there's the motor in the bottom, and the rotor on top, the flywheel again turning at motor speed, and the rotor 1/13. You can also see the swash plate under there, the black Bakelite object. Now this is a single rotor tail rotor configuration, and the tail rotor is driven by the separate motor in the nose, that little blue motor there. It in turn has its voltage controlled by the flywheel you see there, so that if the model changes direction, the flywheel will precess and change the voltage. Those are the solenoids which control the black swash plate, and there's the harness above the center of gravity. The cable has 9 conductors which control the various solenoids and, of course, the power of the motors. Notice his hand moving laterally. The flywheel moves fore and aft. But once things are spinning, then the rotor will follow exactly what his hand does, due to the gyroscopic effect, of course. As his hand moves left and right, the rotor will tilt left and right. And now we see that there's quite a breeze here. That's the reason for the smoke. And he is, in fact, able to control the model without having to wait for flat, calm days, and can fly it where he wants to send it. With this model, he went to Buffalo to show it to Larry Bell, whom he had met through a mutual friend. And Larry Bell was instantly fascinated, not only with the model, but with Arthur Young. By the way, notice that landing gear. It's very important because you're going to see a lot of it later. But here's the little wheel landing gear, which was used for the fancy demonstrations in the Bell factory and in many other places. So Larry Bell and Arthur got together on an agreement, and Arthur went to Buffalo in 1941. It was November 1941. I went along with him to help carry the luggage and be his assistant. After the arrival in Buffalo in November 1941, 6 months later, we got a separate project started in the village of Gardenville, New York, in what had been a garage. And here we are illustrating the design part of the project. There's our first transmission drawing. And then, more important, we had an excellent shop right there where we could make the actual parts for the helicopter. For instance, here's our assembly of the first machine. That tail boom was made in a nearby Bell plant. Here is a landing gear very similar to the landing gear that we had on that model which you saw. Now here we're removing the shaft from the tail boom, and we had just been running it up to see if it was okay and the bearings would work and so forth. That pulley to the left there was used to drive it up to full speed and make sure we had no resonance. There's a pretty good view of the garage as a whole and the first test bed really taking shape. There's the mechanism that the first machine had, its stabilizer bar, and of course above it the hub ready to accept the blades. The blades were very similar, by the way, to the model blades. Now, we used very few drawings when we came to things like the fuselage, which was mostly plywood beams, and we improvised as we went along, of course. Naturally, we had to have drawings for control parts and transmission and so forth, but for instruments and things we considered unimportant for tolerance purposes, we simply improvised as we went along. Now here's the same boy who had learned how to make the model blades in mass production, making full-scale blades to almost exactly the same design. They're solid wood. That cam causes the saw to follow, make an airfoil shape. The leading edge has a metal insert, as the model blades had had. We made two different airfoil sections before we were through, the 0012 and also a 23012, which was not as easy to smooth out as 0012. Now here's a shot we made later to illustrate to Bell engineers what was involved inside the helicopter, and it shows parts of the transmission in the very first machine. This is the freewheeling, which those of you who know Model 47 will recognize right away, except that instead of 16 slots, we later had to go to 32 slots for those rollers. Now, Arthur had thought that Bell would be able to provide him with transmission designers who would know far more than he did. But to his surprise, Bell was unable to help at all with the transmission. So Arthur merely made a copy of his same transmissions he'd used in the little models. But this is 6 times larger in size, otherwise almost identical to the model techniques. The transmission is a double planetary with free floating pinions. Here the freewheeling is almost assembled, and as you see, it is the ring gear for one of the stages of the double planetary, so that in one direction it was perfectly free and in the other direction it would lock up, similar to the coaster brake on a bicycle. Now here are the 2 planetary stages. The one on top happens to be the lower one, at higher RPM and lower torque, and the bigger pinions on the bottom of the upper stage driving the mast. Now every new project, of course, has to have a ceremony of rollout with dignitaries, and we had to have ours. So came the day, exactly 6 months after we got to Gardenville, that we had what we called our official rollout. And the girl on the left there is going to try to break the champagne. The second try, she makes it, and we're ready for the big moment. Those 2 landing gear legs have been put on after the nose got out the door because they're much too wide for the door. We managed to get it out, but we were unable to start the engine, and so ignominiously it had to be towed back by my car into the garage. You can see we had pretty good winters in Buffalo even back then. This is December 18th, just over a year after we got to Bell, and 6 months after this project in the garage was started. Now here's a later rollout. We've learned the drill of how to put the legs on much better at this point. The garage is still a Chrysler agency. It was restored to its original purpose after the Gardenville project was finished. The Gardenville project lasted exactly 3 years, from June of 1942 to June of 1945. The agreement that Arthur had with Larry Bell was to make a one-place helicopter to demonstrate the principles, and then later to make a 2-place helicopter so Larry himself could get a ride. Details of the landing gear are rather amusing here. You notice the black tube at the bottom there is a tension member, and then outboard there is shock cord so that we get a resilient effect. You can see the fuselage is hardly completed, but there is a wooden bench for the pilot operator to sit on, and the object here, of course, was just to get the engine running with the rotor and make sure we had a compatible mechanism without large oscillations. That's just the dolly that we wheeled it in and out on, and there's a pretty good view of the test bed in the configuration where we got the first mechanical problems solved. That shows how the rotor is free to move in a seesaw direction. Here's our auxiliary power cart, the mighty APU, consisting of 2 batteries in series. And by this means we managed to give the rotor engine enough of a kick to start. Now we had no clutch at this point, but we could rotate the rotor ahead of time on the freewheeling, which we did, so that there was possibility that the poor engine could get started without all the inertia of the rotor. Nobody in the cockpit, you notice, not exactly recommended these days, but you can see that we're trying to work on getting the mechanism to run properly. We had a lot of trouble with the carburetor and torsional oscillations at first. Now here Arthur Young's trying his own helicopter, sitting in on that bench and testing out the controls to see if their sensitivity is about right and so forth. We're holding him by ropes, again attached above the center of gravity, to prevent him from sliding and slithering around too much. But he wanted to see, of course, right away whether we had about the right power, right control sensitivity, and so forth. Now that's just to illustrate the amount of wind in this case because our first problem immediately encountered was very severe vibrations whenever he was hovering in a breeze of about 20 knots or so. We always said he flew about 3 feet up here, but he never quite got that 4th foot off the ground. About this time we had our first setback. We had a visit from a Bell executive who was a pilot, who felt that he should be the one to make the first flight. And so he came to join us one day near New Year's of 43. And here he is without his safety belt fastened, and he's holding on by means of the controls. Now watch very closely because we're going to have our first bad episode here. He's thrown up through the rotor. He landed in a snowbank to the left there, and fortunately his injuries were limited to a broken left arm just above the wrist. In fact, in a matter of only days, he was able to go about his business. But we were set back considerably, and took us a little while to rebuild our test bed. Here it is rebuilt. Notice that the engine is flexibly mounted in the pylon there, and that it's a vertical installation very similar to where the electric motors for the models had been, right in the center with the shaft vertical, which was part of our development problem I referred to earlier. This shows a little bit later in spring, and Arthur Young will show the throttle in his right hand as he twists it, and the lever in his left hand is known as the pump handle collective. We'll explain more about that later. Now here he is running a test in the yard, and he is showing, is tethered to the ground in the first place here, and I think you can see to the left of the machine along the fence there a cable. That cable is holding the machine. We do not have the beautiful shiny tail boom anymore here because, of course, we lost it in the wreck. But here we have a welded structure instead of a tail boom, and the back end of it is attached by a cable to the man over by the fence holding that dial there. There you can see the method of measuring the torque, and since we know the force there, and hence the torque, we know the RPM, we therefore know the power very exactly. The engine is 165 horsepower, 6-cylinder opposed Franklin, and much to their embarrassment, we were always able to check up on the power output of the engine. At the same time, we wanted to know about our lift because all our calculations on the performance had been extrapolations from model data. So naturally, we were anxious as early as possible to find out how we were doing. Arthur had learned to measure performance of models in a hover very accurately and beautifully with apparatus that he had developed. And he tried a tremendous variety of airfoils and combinations of RPM, solidity, and so forth. But nevertheless, extrapolating to full-scale Reynolds numbers, we were very anxious to double-check. And incidentally, we had built 2 different transmission ratios. One was 9-to-1, and the other one was 10.5-to-1. Here is the Chatillon scale, which is measuring the excess thrust. Now, we move a month or 2 later to May of 1943, and the pilot is no longer Arthur here. This is Floyd Carlson. He was a young man who had been hired as a test pilot for Bell's fighter planes and had been assigned to the project even before we got to Gardenville, or at least shortly after we got to Gardenville, I guess. Floyd immediately learned how to hover as soon as he tried here, and you can see that we have excellent hovering stability. He is tied with the cable to the ground, and you can see the trapeze there attached to outriggers above the center of gravity. But even though he's able to fly the machine so well, Arthur didn't want to let him fly free yet, perhaps because of our accident. He felt very conservative and wanted to be absolutely sure before Floyd could fly in the sense of going from one place to another without that cable underneath him. Here, Floyd's going to do the first 360-degree hovering turn while Arthur watches from the ground. This control system I'll tell you a little more about now. Floyd's left hand there is on the pump handle collective. He has no rudder pedals. His left hand, when it moves horizontally, controls the pitch of the tail rotor and hence the direction of the machine, whereas up and down was collective pitch of the main rotor. His throttle is on the cyclic pitch in his right hand. Now we have a shot from the roof of the garage, and you see that he's about out of ground effect. He's going to be able to wave at us a little later because the collective pitch forces are balanced. Now we tried many different control systems, at least a half a dozen, but this particular one is the one that was used at first for all the free flights, and 6 of us learned to fly this machine by this tether technique with no rudder pedals. He's going to wave at us there, and he gets the machine pretty well buttoned up right after that. Now here is a scene very reminiscent of that model scene where Arthur tried to shake the model by shoving its legs, and sure enough, of course, full scale is equally solid. It turned out later we almost had too much hovering stability, but this certainly was spectacular and very nice at this point, especially since Floyd had to learn on his own hook of what the characteristics of the machine were. It was very nice to have it respond so slowly. Now we're going to see the more details of the actual structure that was used on Ship 1. This project was known as the Gardenville project, and the helicopter was known as Model 30. Now there's our first rotor brake. You can see that spring is really here. We're in June of 1943. Notice as he pulls the pitch up and down that the stabilizer bar itself moves up and down. It's driven by a separate outer tube from below because the rotor is clamped to the mast. The device, which you can just barely see through the bar there, is an enormous clamp so that the mast did not have any splines or stress raisers. The only way we drove it by the transmission was a brazed piece at the bottom which had splines on it. In this way, we felt that we had a reliable structure with uninterrupted path for the large force of torque. There's the cyclic pitch, which is very conventional. Inside the bar are mixing levers here because we do not have the flywheel, of course, and so Art had no way of controlling the helicopter by pilot motion unless he introduced levers inside the bar. They're called mixing levers. At the time we called it the fixed stick control. And in that way, that was the first major invention that had to be added after we got to Gardenville and before free flights could be made. Now, Floyd here is showing us the general structure, how the rotor is free in the seesaw direction, and what the general arrangement is. There's the throttle with conventional linkage to the carburetor. And that is the chain controlling the pitch of the tail rotor with an Acme thread there when he moves his left hand horizontally. And that shows the tail rotor with quite considerable over-design because, as you'll see, the parts are very massive. We later learned to make them lighter and learned the hard way about fatigue failures in the process. This is still not considered a free flight because there's a man holding each leg, and Floyd is being taken out to a tie-down place out in the meadow there, a new tie-down that we had put with a cable attached to an old truck chassis by the side of the field. Floyd is going to try to do what Arthur tells him to do here, and this is really hovering practice, control practice, of course, before going on into free flight. Now here comes one of the very first free flights. Sorry it's light struck, but as Floyd flew around the meadow, creeping, as you can see, gradually he would get into the way of the sun early in the day or toward evening. Here's a less light-struck shot of the same scene. You can see how he flies around this newly mown field, which was much too small for him really to do any decent exploring of the property of the helicopter. But right away he found out that he had tremendous stability but not enough controllability, that as soon as he flew with any speed, even that walking speed there, the forces tended to rock the bar around and he would have to counteract with his stick. Accordingly, we decided that perhaps the bar should be made to follow the mast a little more rapidly. Here we are measuring, very similar to the work that Art did back in Paoli, and you can see the angle that we go through, and then clock, of course, how fast the rotor is following the mast there with a stopwatch. This resulted in our putting dampers on the bar. They were automotive shock absorbers, which we found also were manufactured nearby in Buffalo. Now Floyd is able to fly definitely at reasonable speeds, but actually only up to about 20 miles an hour when he encounters the same violent vibrations at twice per rotor revolution, which Arthur had already uncovered during the hovering with the smoke blowing in the yard months earlier. But the vibrations were so severe we decided that they would definitely stop the project until we did something about it. We decided that the rotor should be stiffer in the chordwise direction. And you'll see here the illustration of a flexible chordwise rotor. Arthur always liked to go back to model work instinctively. For years after he joined Bell, he continued keeping the model techniques alive as a method of studying problems. We cannot say that this model actually gave us the numerical amount of stiffening of the rotor that was required, but nevertheless it was a big help. It also showed that we were nowhere near the phenomenon known as ground resonance, which had been plaguing articulated rotors at the time. You'll see as the RPM gets very high here that the model gets fairly wild, but it's a condition under which the main big machine could never operate, way beyond its operating regime. Now, 19 days after we decided to stop flying and go after the problem, we wheel the machine out. Just clearing the door there is a mechanism on top of the rotor, which was thought of by Floyd Carlson. And we called it the Swedish yoke in honor of his background, having been brought up in the Swedish-American community of Jamestown, New York. At the end of the yoke of each blade is a socket, ball and socket joint, so the blades are still free to change pitch. And as they cone upwards, they stiffen the structure, and the result is that the blades were stiffer in the chordwise direction. And hence the machine could be flown faster than the 20 mile an hour, which had been stopping us before. Still no clutch, but you notice we're very sophisticated in the technique now. Only one man needs to run with a rotor, and away we go. Here we are before a free flight out in the meadow to see how the device works, and of course we're climbing all over it to make sure all is well after it's done some tie-down running. So he gets some fuel put on board, and he starts to hover. That's a good illustration of the two control levers, the pump handle collective and the cyclic with the throttle on it. Right away, Floyd was able to fly faster than the 20 miles an hour. So the next stage in the program was to find some place where he would have a little more space, because this field behind the garage was nowhere near big enough to do some really good testing of the machine to find out how fast it would fly and so forth. So we put wheels on the machine, which we had previously designed and built and had all prepared, and took off the tie-down outriggers and wheeled the machine behind a car, towing it all the way through Buffalo traffic to a little airport known as Military Road Airport on the west side of Buffalo, near the river. There it is, and we're about to make forward flight tests. We didn't trust the airspeed system that we had, so we used my car and its speedometer to check the speed of the helicopter. Right away, Floyd found as he flew faster that he required considerably less power. We knew this would be the case, but we didn't know the magnitude. And of course, he was rather embarrassed when he began to fly as high as the treetops without meaning to. Notice the fuel tank there, right behind the transmission. It's a gravity fuel system in this case. Notice also that rear landing gear wheel, which is much too robust. The tail rotor is straight back and very near the ground. We're going to see much more of those two parts of the helicopter a little bit later. So these were our first really free flights. There were a lot of people watching. Arthur Young's dog, named Brian, was the first passenger. He got a ride even though it's supposed to be only a one-place machine. Anyway, back at Gardenville and back at Arthur Young's technique for model work, here we see a U-control model operated by Charlie Siebel, who had joined the project some time before. This U-control technique had been worked out by Arthur in Paoli, Pennsylvania, long before joining Bell. And we illustrate it here to show two things. One, the fact that these models continue to be a large part of the project, and two, we're actually measuring the speed-power polar. We know the radius, we know with a stopwatch the time, so we know the velocity. At the same time, we measure the power of the watt meter, and you can see it being written down over there. And so we know the speed-power polar. That's Tom Harriman taking the electrical data. So we got excellent curves, although they weren't, of course, correct in absolute value. They gave the shape of the speed-power polar. And unfortunately, of course, we need some more model blades. But that is a very minor point by this stage. Now, since we were able to get flights up to reasonable speeds, like 70 miles an hour and so forth, we had to dress up the helicopter. Still no clutch, but publicity had already been gotten out. People came in cars to watch what was going on. And Floyd's next question was the good old cocktail hour question: what happens if the engine quits? We had to show auto-rotation. Arthur had already shown it in model form to Larry Bell when he had auto-rotated a model in the factory, and it had landed without power, and its cargo was an egg which was not broken. But nevertheless, in full scale, we had to show what would happen. And we weren't too successful at first, as perhaps this scene forebodes. We towed the helicopter to Gardenville Airport, which was much nearer where we were. It was a grass field. Here's the technique of towing down a country road. And in the helicopter itself there is both Art Young and Dave Foreman, who was the project man assigned by Larry Bell to look over what we were doing. We get to Gardenville Airport, and immediately Floyd makes auto-rotative descents. Here's the first one, where he lands with considerable forward speed and a mild flare. He decided he should flare some more in order to kill a lot of that forward speed before touching down. So here he does. And the third time, he flares even more. You'll have to look very closely because the camera ran out of film, and we had to take the picture on the leader. Now watch extremely closely, and you'll see our third attempt that Floyd made. There it is on the leader of the film, and pieces are still falling out of the sky as the film proper starts. And there is the wreck. We rushed up to Floyd and said, "Are you all right?" And his answer was, "Yes, God damn it." But of course, right away we started talking about what happened, and we saw that a bolt had failed at the bottom of the tail boom attachment, but that the up force on the boom had been much too hard during the flare. There's Arthur lost in thought, looking the situation over, as Floyd is saying we should have a different landing gear configuration and perhaps raise the tail rotor so that it's possible to land the machine in a flare. Meanwhile, of course, we had lots of outside help, because you get consultants creeping out of the woodwork from everywhere to help as soon as you have any trouble. But in spite of that, we were able to hold a meeting more or less right on the spot here. I mentioned that Arthur's agreement with Larry had been that 2 helicopters should be built, and that the second one should be two-place, passenger carrying. So we decided that the best thing to do would be to finish Ship 2. It was almost finished, as it was, and concentrate the flight test efforts on the second helicopter. Meanwhile, however, it was surprising how many of the parts of this one could be salvaged. You can see our consultant there sort of won't quit, but that's the way it was. So we're removing the blades here, tip the machine up and take a look at whether things will still turn. And lo and behold, there was a lot in the transmission that was still okay. The stabilizer bar is a bit bent. The Swedish yoke is the worse for wear. And of course, the tail boom is no longer existent. But you can see the freewheeling still works. The mechanism turns backwards all right. And so forth. This is early September of 1943. It's just 3 months after our first flights, and we had our second setback. So now we have Model 30 Ship 2 being rolled out. The Swedish yoke is still there, but it's down in the plane of the rotor, so we called it the Diamond Truss this time. And here are shots that were made later after much successful flying, but they illustrate the control system. These were made for Bell Aircraft's standard public relations department. You'll see that this time we do have rudder pedals and we have a collective pitch in the conventional location. Although at first we merely had the pitch between the two seats, and Floyd, when he flew from that left-hand seat, had to swap his hands. This we never were successful with, and after Floyd had a near miss with it, we decided to add a second collective pitch lever for his left hand when he's in the left seat. We knew about Sikorsky flying their R4 helicopter with only that one that you see here between the seats, but we never succeeded really in doing this. Now you notice that the bar didn't move up and down. We have a much better, more sophisticated design. There are the pedals which control the pitch of the tail rotor, and the tail rotor has been greatly lightened. We did have a fatigue failure of that particular tail rotor, but Floyd got it down okay. Now we also have a clutch at last. It consists of putting one of the ring gears in bearings, and then a brake band around that, like a Model T Ford transmission. And then when you tightened the brake band, the ring gear was locked in place, and power went to the rotor. Actually, we usually had to cheat and have an assistant throw an extra toggle and actual positive lock, but it was a clutch at least. Now this machine did a great deal of flying. You can see the little Fram dampers there to look at vibration frequencies. Many rescues and demonstration flights were made with this helicopter. Floyd picked 2 fishermen off the ice with it. They had gone out ice fishing, and the thaw had come and their truck had melted and disappeared, and they were unable to get to shore, so he brought them in one at a time. They even wanted to bring their catch with them, but he wouldn't allow that. The ship also was used for rescues of people in needing medical attention in isolated farmhouses and so forth during severe weather. Now, at last, Larry Bell is going to get his ride. At about this time, we felt rides could be given, and it's early spring now of 1944, and Larry has his ride. Correction, it may be late in 43, just before winter. Now here's a demonstration indoors. This is the first flight in the Western Hemisphere indoors of a helicopter. We knew that the Fokker-Achgelis helicopter had flown in 1936 from Bremen to Berlin, and in 1937 it had hovered for a full hour indoors in the Deutschlandhalle in Berlin. But this is the first time in the Western Hemisphere. Floyd had some trouble with the dust, but he had practiced in the morning. And the only problem that he really had here was the searchlight. I think you can see that he's trying to avoid looking ahead here and getting out of the light as fast as possible. We all complain sometimes in engineering circles about having to give demonstrations. But we shouldn't, because all I can say is 'twas ever thus. Even in those days, with our limited resources, we had to interrupt development programs in order to demonstrate. This was for the Civil Air Patrol sort of celebration. It's April of 1944. Now we go to July 4th, 1944, in Civic Stadium. And here is Ship 1, rebuilt and rechristened Ship 1A. Notice the tail rotor is up in the air, and the rear wheel is no longer so robust. It's pushed forward so that Floyd is able to land in autorotation in a flare. This is a celebration for defense plant workers in Buffalo Civic Stadium. You can see the 4th of July fireworks getting ready to go off right behind him there, but luckily he didn't get too near them. Now, after this demonstration, it was decided that we should do some professional flight testing with this helicopter. It was against Arthur Young's wishes. He wanted to go on with more radical development work, but Bell felt that we should learn more about how to make actual measurements in flight test and see what we had. Those two movie cameras there are below a 35mm one, and above is an ordinary 16mm one giving the general view. The lower one focuses on the instruments. So we have a rather crude but effective photo panel. At about this time we were visited by a delegation from Curtis that had been invited by Larry Bell. One of the members of the delegation was a young engineer by the name of E.J. Ducaille, who later became president of Bell Helicopter in Texas. Here's our voice communication. Of course, we didn't have telemetry or anything like that. And Floyd is going to make climbs all the way to 5,000 feet, various air speeds, gross weights, RPM, and so forth, and also autorotative descents. Now, Arthur Young himself flew this helicopter in this configuration around the field. Unfortunately, we don't have a movie of it. I wish we did. But this is the helicopter that is now at the Smithsonian in Washington. Notice that the magnesium tailboom has been rebuilt also. Ship 1A is really a fairly complete vehicle. About this time, we decided that we should build a third helicopter. It would be a terrible shame not to incorporate the things we'd learned in the first two and try to make a product. But Bell management told us we were not to do this, that all products were to be designed in the main engineering department. So, nevertheless, we went ahead building a third helicopter, calling it a test bed, on the grounds that we had to gather more data for the main engineering department, which was in fact true. And at first, we weren't aware of the fact that our third helicopter might possibly become a product. Now you're going to see the instrument panel here, and just to the left of Floyd's hand is the tachometer unwinding. So when the needles are split that way, it proves you're in auto-rotation because the engine is then turning slower than the rotor. You can also see the altimeter unwinding there. The instrument above, surrounded by aluminum sheet, is merely the clock. You can see a rate of descent there too. Now here's a still from the 35 millimeter camera, typical of what gave us our data, and we got very reproducible, beautiful performance curves which would hold up even today. The method of doing so was merely to take many points, which was, of course, quite easy to accomplish with this simple equipment. Very little problems, very few problems with the instrumentation. Now here's a descent toward the end of a measurement from altitude. Floyd decided here to go back to the Gardenville plant. Of course, we no longer had to be towed along the road or anything, so he flies back to visit his friends who are still working on the project on the Model 30 Ship 3. Now, here they are waiting to watch him arrive. There's our friend, the furnace man, and here is the boy who made the blades and one of the machinists. The total number of people on the project never exceeded 32, although there was some attrition and interchange, but that's all that we ever had working at any one time at Gardenville. About this time, we'd had a visit from Sikorsky in the form of the U.S. Coast Guard flying two R-6 helicopters. We interchanged rides with them. Arthur knew Igor Sikorsky well, greatly admired his work. He considered it right in the line of the work already done by Fokker and Fleckner in Germany, Breguet in France, Dascagno in Italy, and so forth. And of course, his own work here at Gardenville. Notice the fuel tank is no longer on top. It's down below, and we're using a fuel pump. That's also one of the things that was new with Ship 1A. Now, in that group of people you see behind there, 8 of those people are still working in this year of 1977 in Bell Helicopter Textron in Texas. Now Floyd flies away from them there, and they go back to work after they say goodbye to him on Ship 3. Unfortunately, we have almost no shots of Model 30 Ship 3 because it was rather illegally constructed. It did, in fact, become a third helicopter, although our orders were to build only the 2. But here it is, and you'll see the 4-wheel gear, the welded chrome moly steel sort of construction of the center frame. There's a basket holding the transmission, and many features that later became Model 47, of which 10,000 were built. The only thing really lacking is the bubble. There, Larry Bell is getting a ride, so Ship 3 is now sanctioned, and about this time it was decided to make production drawings and actually make a production helicopter along these lines, in spite of the fact that the main engineering had also been working already on somewhat larger helicopters. Notice that there's no floor there even, so that if your shoe became unlaced and fell, you lost it forever. It was quite a thrill getting power-off landings as a passenger in this machine. Shortly before this, we had been joined by a natural pilot by the name of Joe Mashman, who later made a tremendous career around the whole world of demonstrating Model 47, of which this is the direct father. Of course, the next thing was to make production drawings, which Arthur Young supervised, and to make forgings where we had used hogouts and other production ideas. Of course, this involved more people, and gradually we went ahead and made 10 Model 47 helicopters, almost identical to what you just saw, except for the addition of the bubble. And also, on some of them, we decorated the tailbone by wrapping it with canvas. That is the birth of the Bell helicopter. Thanks very much for your attention.
Okay.